Mike Easy, your line is open.
Question about the variable speed units and why you limited it to one manufacturer, because there's plenty of manufacturers out there and some with even higher SEER numbers.
That's right. I mean, do you see higher SEER number for centrally ducted systems or for mini-split systems?
For mini-splits?
Yeah, so these are only centrally ducted systems. We haven't tackled mini-splits yet.
Oh, you haven't? Okay.
Oh.
All right.
You're right, there are a couple manufacturers that now offer these products, but the amount of data that we needed to model them, we could only find from one.
Okay, thanks. Oh, when will the mini-splits be available?
That's going to be one of the big things we tackle in the immediate future. We're getting a lot of experimental test data that we've been sponsoring to help model this type of equipment. The one problem with a lot of the mini splits is that the manufacturers don't, provide extended performance tables for the entire range of compressor speeds. It's typically at one speed, which is not sufficient to develop the necessary performance curves that we need. But we're getting that data that we do need, and the next step will be implementing that within tools.
If I may, I notice you don't have anything in there on, or I don't know about hydronic heating. And how would you deal with radiant cooling?
I believe radiant cooling is one thing that we do have on our task list. I don't know if we've really, assigned anyone to work on that specific task yet, but we haven't really started thinking about how to work on that.
And there is hydronic heating category in BEopt. We haven't done anything specific to differentiating performance for radiant heating, but there are, in fact, I think the last topic here will be a small mention of boiler performance coming up in just a minute.
One last question. What about night ventilation?
There is natural ventilation options in BEopt, and we actually did a little bit of work on giving that category some additional flexibility. And I think it's a bit of an oversight that we didn't present details on that today. So yeah, there is possibilities. That's for naturally driven ventilation. And there is also mechanical ventilation, but maybe not as many control variables as one would like in terms of set points to do something like the night breeze technology, for example.
So, sorry, this is my last question, not to dominate, it's just on our mind here. What about different set point controls?
You want to go to the input?
Yeah.
Can you, for example, we're big on pre-cooling.
Right.
Is there an opportunity to do pre-cooling in BEopt now?
Sure, there is. You can establish set points and set point schedules within BEopt.
Okay, great.
So there's a couple example options here that you could use as a starting point to kind of describe the schedules and temperatures that you wanted to get.
But this is also an example of a category that if you went to the option editor, it would be fairly straightforward to make additional options with other sorts of schedules, give them an appropriate name, and have them show up here on the option screen. Again, user-defined options specific to the situation that you wish to model.
David Beal, you may ask your question.
Hello again. I'm confused, and then I have a question. So should I start with the I'm confused?
Sure.
Let's just, you threw me off with this 5-ton SER21 actually being an SER16. So let's just assume I go out into the field, I write down some model numbers and serial numbers of a 5-ton unit, and I come back and I look on the AHRI website and it tells me the thing is an SER21. So I click on SER21 in BEopt. Is it going to suddenly derate the thing to an SER16 for me without any input from me?
If you use the built-in option, it will. But if you created your own user option, you can basically get rid of those derates. But if you can find a 5-ton air conditioner that actually is a SER21,
well, I'm wondering, are you doing this for the 16s or only to things up over 18?
So when we looked at all the data, we only saw this trend for SEER 18 and 21.
Okay, I probably will never encounter that in the field, so it might not be an issue.
I mean,
but you're saying it just in case I did, and there was actually one that was AHRI rated at 21. It's not. I would have to do that input myself.
Correct. And this data is actually directly from the AHRI.
Okay. So when you look up this 5-ton unit, the AHRI thing says 16, not 21. Okay.
Correct.
Okay.
At 5 tons.
That's what I thought you meant.
Yes.
So if I actually click 21 and it works out to be 5 tons, it's going to be modeled as a 16, however.
I mean, that's what it's kind of looking like on this plot, but basically what it does is it's derating the efficiency of that, so it's approximately that of a SEER21, yes. I mean, it's not taking the inputs from the SEER16, but it's derated. It's basically diminishing the rated efficiency of the subject unit.
Now this actually is a question that caused me to give up using BEopt.
Hey, David, could I interrupt for a second and just make an observation here? You know, that I would say your question about is this applied to less than SEER 18, the answer being no. And so this trend in the D rate starts to show up in the manufacturer's data for SEER 18, you know, and then is a more extreme trend for SEER 21. So.
But it is what I would find in the AHRI website. So I would probably not be putting 21 in. I would click 16 and everything would be fine. I hope.
If you put in a SEER 16 in BEopt, it will always be a SEER 16.
Okay.
There is no D-rate for that built-in option.
And now you're hitting on one of the things that just drove me absolutely crazy. I couldn't figure out what was going on. We have a lot of people that want to put in strip heat down here. So they have an SER13 air conditioner with strip heat, and we say, you know, think about going with a heat pump. And in BEopt, we went from a strip heat to a heat pump. And lo and behold, fan usage went crazy. The cooling amount of energy that the cooling used went crazy. It just was... I think what I'm asking is if it's an SER13, I don't care what size it is or who made it. I want to be able to say, you know, the SER13 heat pump and the SER13 air conditioner, they all perform the same because SER13 is defined by somebody. And that was not the case previously. And we went through a lot of rigmarole trying to match all of those various variables that you say are now gone, and did that, made the SER13 air conditioner perform the same as the SER13 heat pump, but then the SER15 heat pump performed worse than the 13, and the 16 performed great, but the 17 was terrible. And has that gone away? If I step from a 13 to a 14, am I going to see approximately a 10% reduction in cooling energy use?
Yes, those trends have gone away. That was one of the main reasons for bringing our graduate student in to kind of clean up this category, was due to some of those issues that we were seeing in the previous set of data that we had.
Okay.
And there was also, were you using DO2 or we're using Energy Plus?
Unfortunately, we still are probably going to use DO2.
Okay.
I think because we have so much interest in these heat pump water heaters, we're probably going to talk about going to the Energy Plus.
Okay.
Why?
Why
do you ask?
Well, we discovered a particular issue with two-speed air conditioners in Energy Plus that we've since resolved.
So we might be better off sticking with Jesus Christ, how do I make that stop? Sticking with the DO2 for the heat pump in the air conditioner business in the higher efficiencies?
At this point, no, I think we're actually more confident in Energy Plus.
Okay. All right. I think that answers my question, and I'm going to do a little playing with it a little later, and I will, if I find real problems, I'll email it to Scott.
Okay, thanks.
Thank you, guys.
David, this is Craig, and you started to say something to the effect of something that, sort of kept you from using BEopt, and I know that. And is that what you just addressed?
Yes, indeed. I mean, okay. If I can't go to my clients, I can't specifically say you need to use a Trane HP Please ZZZ2 heat pump. I need to say you need to move up to an SER 14. And it needs to perform better than a 13, and it needs to perform the same way, whether it's air conditioning or a heat pump. Yeah.
Well, I agree, and this was, so the issue here is, so a couple comments. One is, remember that I said on Windows that we characterize the windows with U-value and solar heat gain coefficient, but behind the scenes is a very detailed model that accounts for different solar transmission as a function of the incident angle of the radiation, etc. And this is a trend in our work with BEopt, is attempting to allow users simple inputs that they can specify the equipment in a consistent way, in a simple, straightforward way, and yet we don't use simplistic models. And so Windows is one example of that, and now air conditioners and heat pumps are also a successful example from this recent research over the last year and a half that Dylan did that really, he got data from major manufacturers, made a huge database, and basically determined that these curves for non-rated performance at non-rated conditions, the curves are important, but the difference between one product and another in terms of those curves is not important. And that is a major breakthrough in being able to use detailed models driven by simple inputs and getting the kind of consistent performance that you are looking for. I know it sounds crazy, the trend between, a 14 and a 15 and a 16, but we were basically using work that had been done in California, funded by Southern California Edison, with some of the best DO2 experts around, and they had looked at a lot of manufactured data, and they determined typical systems, typical AC systems, but because of the level of detail that it took to drive that model, it was everything that you described. We were stuck with those same issues when we were using the product-specific curves. And so this recent work has really freed us up and resolved some of those problems, I think, and allows us to both have generic models that have a lot of detail behind them, but as you said, you can spec a generic SEER 14 or a SEER 15 or a SEER 16 and expect a consistent performance trend.
I could see where the previous way, if I was actually an air conditioning contractor and had this data at my fingertips and could show, this is why I sell Carrier and don't sell Trane or whatever, I could see that, but I'm not in that position. I'm more in the position of going and talking to a contractor and saying, you'll probably save this much energy by spending a little bit more on an SER 14 or an SER 15 than if you just go, if it's only $300 more, this is how much energy you're predicted to save. So essentially, I went back to our older software and just would use it.
Understood. But now I think you would be able to do the generic SEER level options from BEopt, or if you wanted to look at a particular product, you can also do that without getting into, you know, this quagmire of coefficients for performance curves. So at this point, we feel that you can do both the generic SEER level options and manufacturer products, and do them both in a fairly straightforward fashion.
So basically, if I know the cooling EER and this SHR and the other things you were just showing, then I could enter them for a specific machine. Otherwise, it's assumed to be the same for all of them. Is that what I understand you saying?
Yeah, otherwise it is...
the EER is directly coupled to the SEER, so different SEER levels will have different EERs, but I think we do assume that all the built-in options have the same sensible heat ratio.
Okay. Thank you.
Okay. Any more questions on this topic?
Elia German, you may ask your question.
Hi, I have a couple of questions. One is in the air conditioner inputs, there now is an input for supply fan power rated and supply fan power actual. I'm assuming that these two inputs are used to then affect the EER based on actual operating conditions. Could you speak to how those two inputs are used?
Sure. So you'll notice that in the AHRI testing procedure to calculate SEER, the static pressure assumed across the air handler is very small and not very realistic. So, but this number, this fan efficiency at that static pressure is important when determining something called the gross efficiency. So most manufacturers report something called net efficiency, which includes blower heat. And the simulation engine doesn't want it that way. They want it in terms of gross. So this rated number is basically just to do that conversion. But the annual run, the annual simulation will be, the fan in that simulation will be run using the actual fan efficiency. So we were kind of caught between which value to use, because both are important, but both need to be used to be the most accurate. I hope that answers your question. I know it's kind of complicated, but
yeah. So it sounds like you to come up with the EER that you use to run the simulation, you back out what that EER would be without the fan, using the fan rated, and
exactly.
Then you back in the actual fan.
Yep, that's the only time that fan efficiency rated is used, is when coming up with the inputs that the simulation engine wants from the ones that we specify in BEopt.
Okay, great. And then my other question is that in the past, NREL has recommended using the DO2 version of BEopt, and it sounds like now you're moving to recommend the Energy Plus. Is that the case?
You know, we've discussed this a lot internally, and I think things are approaching in that way. There were limitations that we hadn't overcome yet in Energy Plus that are now kind of going away. The latest version 7.0, has made a lot of enhancements with computational time, which is one of the bigger drawbacks between the two. But we keep kind of uncovering small little quirks of DO2 that we really can't get resolved, and that aren't there in Energy Plus. So, and then Energy Plus, you know, you can model heat pump water heaters, you can model dehumidifiers, and there's small other issues where we think that Energy Plus is doing a better job. So if you're willing to deal with the added computational costs associated with Energy Plus, I think we're safe in saying that that's the route we'd recommend.
Okay, thank you.
I would agree with that. I think the unfortunate, there was a little trade-off, is that Energy Plus got faster. We made some decisions to improve modeling robustness that we took back some of that speed gain. So there's still a runtime penalty, certainly, for running Energy Plus versus DO2. But as John said, the modeling capability is looking sort of better and better, and probably will in the future as we do additional advanced technologies.
Jacob Dunn, you may ask your question.
Hi, yes, I had a question about the thermostat settings and schedules. I was wondering if there's a way to specify whether or not the system is operating in the auto setting versus just on or off, if there's a way to take that into account or not.
Auto setting on the thermostat?
Right, yeah, so, when it's in auto, basically the coil and the fan cycle on and off together, and when it's on, the fan is constant and the coil cycles. And I think I've opened up some back-end simulations and found that it looks like it's modeling in auto the whole time, but it seems like this would have an effect on overall energy usage, and I was wondering, I haven't really dug into the user options of the thermostat settings and set points, and I was wondering if there's any type of way to take that into account.
You're definitely right that would have a huge impact on the energy consumption, and that, yes, right now we are only modeling it using the auto mode. I can't think of a workaround offhand to model constant fan. Maybe we could do something kind of post-processing or something like that, but right now you can only model the auto mode.
Okay, so that makes sense, because we were doing a project here at the Integrated Design Lab in Boise, Idaho, and I ended up just basically having to, extract the IDF from the BEopt model and then put in a separate Energy Plus template just to model that different type of operation. And I'm glad that I just didn't miss something that I could change in BEopt.
I'm not as familiar with DO2, but I know this should be fairly easy to handle in Energy Plus. I think there's a pretty easy way to model the continuous fan operation, so that could be something we consider adding in the future.